Hello everyone. Hi. So briefly about me. Hi, my name is Bhavik. I head the data science and analytics teams at Shadi.com. Right. So basically trying to get people married. Right. Now some people think we're making people's lives amazing. Some people think we're making people's life miserable. But the opinion is always divided on that. So. So prior to Shari.com, I have worked at a few different companies, Pepperfry, Microsoft, Amazon, IBM, primarily in the data science and data warehousing related fields. Been in this field for about 10 years now. Has been an amazing experience. Just as an anecdote, so one of the things that really got me super excited about data science and machine learning. There was this one time when I was having a discussion with one of my professors, and it was just a project that we were doing in machine learning, and we had built this model to do a bunch of things, and we had this discussion around what aspect of the model was working and what wasn't working, and the discussion sort of went like this. So my professor, he was like, I think the model must have thought that the data here is like this, and hence it is predicting like that. The model must have thought. And at that point of time, I didn't seriously realize it, but later on I realized that we were talking about a model, and we were talking about it thinking, right? And that is sort of something that really got me interested in this entire piece of things, where you can make things other than humans think, right? We never really talk about anybody thinking. We don't even talk about animals thinking. It's just humans where we use that term that this person must have thought in this way, or this person must have thought in this way. So when we start talking about a system thinking, that really sort of got me very interested in this entire piece that is data science and machine learning, and since then it has been an amazing journey. Coming to Shadi.com, right? I often like to ask people, what do you think Shadi.com does in data science, right? So anybody who has any ideas? Recommendations, right? That is one thing I always get. What else do you think Shadi.com does in data science? Right. So sort of recommending and ranking people. Yes. Classification in what sense? Right, which will again come down to who we recommend to whom, right? So that is one business problem that really does that. Yes. Right. So very nice. So we do a lot of photo detection, where we try and identify if a photo is genuine or fake. Right, we do a lot of computer vision to identify whether a photo is genuine or fake. We don't do a whole lot of thing to identify if an image of a good quality. It's basically a bunch of rules that says ki अच्छे size का image है and all of that, then it's of good quality. But I don't know whether Shadi.com does photo matching, but there are other Indian matrimony nowadays does photo matching also. No, so I'm looking at some and I see nowadays this is a photo match for your son. So yes. So yes. So all of the things in matrimony sort of have started going down that route, where they start looking. So I often tell when I talk to people in my team, I often tell that this is the age of Tinder, and everything is decided basis photos. So because that is how Tinder works, right? You look at a photo, and earlier people used to look at a lot of things. They look at hobbies and education and this and that. Today the first thing is photo, and after that they'll think of other things, right? So I mean, age of Tinder, anyways. So yes. So we do some of that as well. What else do you think we do? Sorry. Exactly. So again, there is a lot of things. So one of the things that I want to put, establish a little bit of perspective here is, Shadi.com started in 1996. Okay, our biggest competitor, Bharat Matrimony or Matrimony.com, started in 97, 98. Just compare this, Flipkart started in 2008. Snapdeal started in 2011, right? So e-commerce in India came 10 years, 12 years after online matrimony came in India. So you can imagine how mature the industry of matrimony is, and how important it is for Indians, right? They were willing to go online for nothing else but for getting married, right? So so that just puts things in perspective. But so coming to fake profiles, right? We are in this business of trying to connect people with other people, right? And so this is the entire social business. What happens in this is you have Facebook, you have Tinder. They are all in the same sort of industry, right? They are trying to connect people with people. And if you see the biggest problems that all of them face, right, at least definitely Tinder faces, is the problem of fake profiles, right? Because it's free to create a profile. So, you know, people end up creating fake profiles all the time because they want to see somebody else's details, because they just want to see who's on the market, right? Whatever. So they want to do anything, and they just create a profile. So we all have this problem, right? I'm sure very often you might find in Facebook where you get a friend request from somebody who you have no idea who that person is, but you have a lot of mutual friends with them, right? And that's just a fake profile. They sent a few requests to some of your friends, and those people accepted, because, you know, we usually don't think a lot before accepting friend requests these days. So they accepted, and so now, you know, you have a lot of mutual friends, but you have no idea who that person is, right? So that is, you know, one thing that really every company in this industry struggles with, which is fake profiles, right? So just like Facebook and Tinder, Shadi.com also struggles with that problem, and we try and do our best to build as good models as possible to avoid that. And, you know, again, something I often tell people is that, you know, the thing about fake profiles is it's like a chore police problem, right? As the police get smarter, the chore also gets smarter, right? So you build nice models, you build interesting models, and the person who's trying to create a fake profile also figures out how your models are working, and then figures out a way to work around them, right? So you have to be continuously on that, you know, in that process of improving your systems to ensure that, you know, whatever loopholes people have figured out are then closed and fixed. So that is definitely there, right? There are a bunch of other things that we do as a company. There is, you know, one of the things is we have a ton of data, really. First thing, we've been around for 20 years, right? We get about 20 million profile views every single day on our platform. So that's 20 million a day. You combine and multiply it by 400 days into 20 years, that goes into trillions, really. We have 20,000 new people registering with us every single day, right? When I joined, I was surprised so many people are looking to get married, but apparently it's true. So yeah, so that is the, you know, and the best part is they provide us with a ton of data about themselves, right? Because they are looking to get married, they want to. So really there's a lot that can be done, and we just, you know, are scratching the surface in that sense. But there's a lot more that we do in terms of, you know, identifying leads for our sales teams, right? Which is a hot lead, warm lead, you know, who to call, who not to call, identifying the kind of discounting to give, identifying emails that we can target. Obviously, there is the fraud profiles, the fake photos, trying to autofill things for people so that the registration process is faster. There is, of course, the image pieces, the image matching, the image detection. There is the entire piece around recommendations, obviously, which is the topic. So let's talk about recommendations, right? So what is really recommendations, right? Now, a lot of you must have seen, and I often find this one of the best examples. You know, you might go to YouTube once in a while, right? And then you view a video, or maybe somebody sent you a link and you view a video, and then you realize that, you know, after an hour you are still on YouTube, right? And you're still viewing some video because it keeps throwing the kind of videos that you would be interested in, and you would click on it and you would view it. It's just difficult to sort of, tear away from that. So YouTube does like an amazing job with recommendations. Of course, there is Amazon, right? Amazon has done a lot of good things with recommendations. It's heavily relying on its recommendations to boost its sales. There is Netflix. Netflix is known for one of the best recommender systems in the world, right? The minuteness to which they go to the nuances that they try and identify and feed into the recommender system is just amazing. So there are actually a ton. You can think of even Facebook, right? Because it tries to put the feed in such a way that this is the next article you might want to read. This is the next article you might want to read. And Facebook and LinkedIn, and they all do that, right? So it is really, recommender systems is something that has crept across almost everything. One of the things that when I first went to US and I got really interested by is Pandora. I don't know how many of you people have heard about Pandora. It's not so popular in India, but in US it is very commonly used. The way it works is you just give it one song or one artist that you like, whose music you like, and then it will keep recommending continuously. It's like a radio channel, except that it is specific to you. It plays music that you like, right? It's your custom, your own radio channel, right? Which will keep, so it's not like a cassette or a CD where you have a playlist and that will keep playing. It keeps changing, it keeps modifying, it keeps introducing new songs. It will do all of that, right? Without you having to do, any real hard work on that. So that is Pandora. YouTube, as we already discussed. I mean, I have some pretty interesting visualizations around how all of it works. We'll go into a little bit of that, but this is YouTube. YouTube has a pretty extensive algorithm around how to give you the next video or the next set of videos, and which is why people get hooked so easily to YouTube. And obviously, one of the things is YouTube has this massive database as well. So they have enough content to give you the kind of video that you would be looking for. One of the things that I wanted to sort of talk about is how do these systems evolve, right? The evolution of these systems. So obviously when YouTube started or when Facebook started, they didn't have this amazing recommendation algorithm, right? So how did it evolve? So I'll take this example of Facebook because it's very easy to elaborate on that. So Facebook, when it started, it had to give you a feed, right? And so it was like, okay, how do we give a feed? So I thought a very simple algorithm. Out of all your friends, the most recently posted post is the one that you see at the top. The next most recent is the one that you see next, and so on and so forth. So this is what I typically call as a sorting phase. They are just sorting. There is no significant intelligence. They are just identifying that one attribute that they want to sort on. In Facebook's case, the recency of the post, right? And they're just sorting it. That is how most of these things start, right? Even when Shadi.com started, the initial thing was, okay, we'll just show you profiles in the order of the most recent logged in profile, right? So the profile that is most recently logged in within your partner preferences, that is what will show up at the top, right? And so that is sort of how most of these companies start. It's just a simple technique, right? They don't have the resources and the human resources and stuff. They're still starting. It's very early days. There are probably 10 employees or whatever. It's just not feasible to build an elaborate system, right? So they start with a simple sorting thing. The next thing that comes is they turn this into elaborate formulae, right? So they'll combine 3-4 different items. They'll generate a nice score. And again, they'll sort by that score, of course. But the point is then they'll come up with intelligent formulae. This is when, you use a lot of statistics. There is, usually this is done by what we call these days the product management team, right? So there is a product manager for, let's say, the Facebook feed, and that person will come up with, what weightage to give to what attributes, right? Maybe recency, maybe how much you like that friend, etc., and then combine it. So 2 times how recent it is plus 3 times, how much liking is there between you and that friend, and so on and so forth. And it will combine it. You will get a score, and it will sort by that score. This is what happens usually after an easy. Still, you don't need any intelligence. There is no significant machine learning involved. You still, before you start with a machine learning team, this is where it is. The next part is where machine learning starts coming in, right? You start building model. The difference between a formula and a model phase is that, right? A formula phase is something that is built for right now. So you have identified what is most important to your users. You found out that, most recently posted item is important. You found out that what is the likability between the person and their friend is important, and basis that you give weightage, right? But what happens is, 2 months down the line, that is not important, right? Maybe likability is more important now, and recently posted is less important, or people are more into recently posted things. They're spending a lot more time. So recently posted is very critical, and likability is not that important. The point is that product manager who built that formula has to again go back, again look at the data and rebuild that formula, which is what the model phase sort of takes away, because then, you just retrain the model will figure it out. The second piece where model phase comes in is when you have too many variables, right? When you have too many variables, you want to consider 500 different variables, and you cannot build a formula on 500 variables. You just can't analyze, right? Excel runs out, right? Because product manager's favorite tool is Excel, right? Excel runs out. It cannot do much, right? And then you start struggling, and you can only use a limited number of variables. And so you start getting into the sort of model phase, right? So one of the times when, some time back, about 10 years back probably, Shari.com was also using a bunch of formulas to determine who should show up in your recommendations, right? And then they realized that, there are way too many variables and we can't manage this. We can't build a formula in Excel, look at the data and figure it out. So we started building models. These are always simple models, right? So at some point they are optimizing one thing, right? So when Facebook built probably some straightforward simple models, it was optimized to identify whether you are going to like a particular post or comment or share or not. So you must have remembered there was a time probably 3-4 years back when every post you would see is either somebody getting married, either somebody's birthday, either somebody having a kid, right? The reason is because those are the posts that get the most likes and the most comments, right? And the model was optimized on which post is supposed to get the most likes. And so the model knew this is the post. It says congratulations, so it is supposed to get the most likes. But then obviously Facebook realized that there was a flaw in that model, right? People are not just interested in seeing who got married and who has a birthday and, who got promoted or who had a kid, right? So obviously people want to see more deeper content than that, right? And so then they start getting into more complex systems where it is, you have a model system phase, right? So another place where I would like to highlight this nuance between these two things is, for instance, I was working at Bing Ads, right? In Bing Ads, the models were optimized about which ad will get a click, okay? So then we would sort the ads basis, how likely is an ad to get a click, because Bing gets money when ads get clicked, right? So, so they would be sorted that way. Then we realized that there were some flashy ads which would immediately get a click because the ad itself is very flashy. It says discount, discount, discount. I don't know what, but the ad itself is very flashy. It would immediately get a click. And then within 20 seconds, 30 seconds, the user would go back to Google or Bing or whatever, right? And so we realized that our model was only optimizing on the likelihood of a click. And so the model would put all the flashy ads right at the top, right? So that was obviously a problem. So we built this model system where we started building another model. There's another model which says, okay, how likely is it that if the user clicks on this ad, the user will stay on that page, right? So there is another model which predicts that. And then we take the output of that model and the output of the first model which predicts how likely is the ad to get clicked. We combine those outputs and then we give a final ranking, right? And this, as you know, is important because otherwise we'll lose users, right? Users will realize that, all the results that Bing gives are flashy and, not really interesting, right? So that is how these things evolve, right? So you have a model phase, you realize there is a flaw, and then you get into a model system phase. Usually what I call is one of the most recent last parts is the micro personalization phase. It gets you so personalized. It is like, it is just for you. Nobody else will get the exact same thing, right? It has built it right for you. Now this is usually a much more complex thing to build, because the amount of data that you have to go through and the way you have to build the model has to be able to understand, and at runtime to be able to say, okay, this is the time when this person. And another thing is here, this is not just micro personalized, but it is also sort of temporal. When I say temporal, it means it is for that particular time, because when I go to YouTube at this point of time, I am interested in something, right? But I go to YouTube 2 hours down the line, I am probably not looking for something, right? Right now I may be looking for some sports things, because India is playing Asian games and whatever, right? And then 2 hours down the line, somebody told me there is this new movie coming, so I am interested in movie trailers, right? And so if YouTube doesn't understand that, and when I'm looking for movie trailers, it suggests me sports, I probably will get hitched off, and I'll go to I'll close YouTube, because I'm not looking for sports at that point of time. So YouTube has to understand that, right? So this is sort of a super personalized, super temporal phase where systems eventually get to, and then they keep working to make it more and more personalized and more micro and nuanced and all of that. So this is sort of the evolution that most companies that you will see follow almost all of these 5 steps. They'll start with a simple sorting technique, then they'll go down to simple formulas, right? Then they'll come down to model, and it depends on, it always depends on how big the company is, how many users it has, how important has it become for it to, build something for specific to its users, very important to its users. Okay, 10% users are not liking it. Is 10% big enough for me to go and change something? When a company is small, 10% is not that big. But once a company becomes big, it is looking to make itself more efficient, and it wants to juice out even those 10% users. So it really wants them also to get the best possible thing. So that is how this thing is, right? I'll start now getting into more of recommender systems, right? Recommender systems, as I mentioned, follow these phases. The type of recommender system that I'm going to talk about are mostly in the model phase, right? And the other ones are probably more extensive. We'll try and touch upon that a little bit. So there are 2 very well-known types of recommender systems. One is called a collaborative filtering system. A collaborative filtering system is simply, user A liked books A1 and A2, and user B liked books A1 and B2. So now, because user B and user A both like book A1, it is possible that user B will also like the other books that user A liked, right? So it is almost, if you sort of, think about it, you go to Amazon and it will say, people who viewed also viewed, right? It will also have this people who bought also bought, right? So these are basically very simple, straightforward examples of collaborative filtering. The second part is called as content based. Content based is where we depend on details of particular items or particular products, right? So because you bought this book, you bought this movie, there is another movie which I know is similar, so I will recommend that movie as well, right? If you often go to Netflix, you will find that because you watched this particular movie, here are some other similar movies that you will like. Or because you watch this particular TV series, here are some other similar TV series that you will like. So Netflix uses content based very extensively. And obviously there is the hybrid recommender system where we combine both of them. So we use the user data and we use the content data both at the same time to build a complete system. Now, coming to how we acquire all the data around it, right? Very often it is very important to understand that your models are only as good as your data. If you're not providing good data to your models can hardly do much. So in what all ways can we collect data, right? There is explicit data where customers provide ratings, there is feedbacks, there is reviews, there is demography, there is all sorts of things that you get from the customer because the customer is telling that to you, right? Explicitly saying that. Now the problem with this type of data is that one, it is usually slightly sparse. You don't have enough of it, right? Not every customer is going to give a rating. Not every customer is going to provide a feedback, right? And plus very often there is often a bias, right? Only customers who are either very happy are going to say something or are very sad are going to say something, right? You do not get the entire spectrum of things. So there are two challenges with this type of data. One is that this data is slightly biased, right? And that this data is usually not large enough. The second type of data, which does not have either of those two challenges, is that you have implicit data. You understand basis, indirect feedback from the customer. If the customer buys something, that means the customer was interested in it, right? If the customer is spending 20 minutes looking at a particular thing, that means the customer was interested in it. However, there are challenges with this type of data as well. Just like I explained you that Facebook example where, you took like as an implicit measure of the customer interested in that type of post, whereas the like was just because the customer was adhering to social norms. Ki birthday hai to like karna chahiye, right? It was not really that the customer was, interested in that thing. So there is that challenge with implicit data as well. So you have to be careful how you combine these two aspects and build an overall piece of information that is large enough for you to build a model as well as not biased. And obviously the last part is you have a bunch of the product information, you have some taxonomy, attributes, descriptions, all of that, and you use all of that information, right? Product information is usually pretty straightforward, no major challenges there. Usually the big challenges are around your explicit and implicit data and how do you combine them to make sure your data is not biased. The biggest challenge that you would often face is data gets biased, and because the data is biased, the model also learns something that has its own bias, and then you are not doing justice to every customer that you have. So that is around data acquisition. Just quickly, collaborative system, I sort of already touched upon this. You have this entire piece of information where you have likes, you have some sort of favorites, you have some emails or whatever, and then you have some question marks, and then you try and fill those question marks around whether the person is going to like it or not, or should I recommend that to the person or not. So this is simply a collaborative filtering, collaborative recommender system, right? Now usually how do we calculate what is the feedback or the interest variable? Again, very similar to what I just mentioned around, there is the implicit piece, right? You have time spent, number of times, basis that you decide whether the customer is really interested. And then you have the explicit around ratings and comments, right? And I sort of already touched upon this, which is better, right? They both have their ups and downs, and you have to figure out a way to combine them in the right manner so as to get, unbiased data truly. Now, what are the simple techniques used to determine, what is what, right? So there is very often, because again, so you should understand this, all of this really happens at a massive scale. So it's not like I have 5 customers and 5 items, right? This happens at a massive scale. So I have to build a way to combine all of this data and finally, at the end of the day, give a way of scoring it, right? And so basis that score, then I'll rank those items, right? That score can come from whatever model I build. The model is going to give a score, and post that score, I'll sort of, filter those items. Now, so I'll just quickly touch upon, how in different ways we do things. One of it is, we do a simple similarity piece where we represent every customer as one, we represent every item, just like the matrix that I showed. And then we generate a simple similarity function basis that I give a score to each item. Now the challenge with this really is this is computationally extremely expensive, right? If I have 20 million customers and 20 million products, it is 20 million cross 20 million, right? And generating this sort of at real time is almost impossible, right? So that is where a lot of the challenges come with recommender systems. So obviously that you do sort of dimensionality reduction and try and reduce the number of aspects, attributes that you're trying to give, but all of that still creates a massive data set. So what we do is we do a simple thing to just solve it a little bit. What we do is we'll use clustering. We'll cluster similar users into a cluster. We'll cluster similar items into a cluster. And then we do cluster cross cluster. So instead of it being M cross N, where M is the number of users and N is the number of items, it becomes MC cross NC, where MC is the number of user clusters and NC is the number of item clusters. Assuming you do a decent job at clustering and get 100, 200 odd clusters, then it becomes 200 cross 200, which is very easy for any system to compute, even at runtime, right? But obviously the quality of this recommendation is not going to be as good, right? Primarily because you have done some clustering, and so some aspect of that information about a customer is lost, as compared to the earlier scenario where you have considered every single piece about a customer, every nuance of a customer. Here you have just, you can sort of say you have stereotyped the customer into one set, right? That this customer belongs to this cluster. That means whatever the preferences of this cluster are, the customer is going to adhere to those preferences. So obviously there are challenges, ups and downs in both things, but these are two very commonly used. There are some other techniques which are used in terms of matrix factorization and stuff, which I'm not really going to go into, but those kind of help with a lot of these challenges and downsides. The next piece we'll talk about quickly is the content based recommender systems, right? Content based recommender systems, we look at how similar two items are, and if the customer has bought a specific item, we recommend another item, right? So if, in a sense, you can think of this as, if a customer liked a particular post on Facebook, and I know there is this other post which is very similar, I will recommend that post as well, right? So if it's a birthday post that a customer liked, and I know this is also about birthday, I'll recommend that as well, right? So that is pretty simple in that sense. Again, the devil is sort of in the details. You start going down and you realize that there are a lot of challenges that come because of the way you have to understand how to identify what is similar to what, right? Because if this aspect is not correctly done, you will end up giving bad recommendations, right? So we'll look at some of these simple things in terms of content things. One of this is called as TF-IDF. TF-IDF is a very straightforward way of getting meaning out of a lot of unstructured data, right? What this simply does is it takes the frequency of an item occurring in a particular, of a term occurring in a particular set, right? So let's say it says happy birthday. So happy is one term, birthday is one term. If you want to say happy birthday is one term, so you have happy, you have birthday, you have happy birthday, right? And let's say it says happy birthday Bhavik, so it is happy birthday Bhavik, so happy birthday Bhavik, happy birthday Bhavik, and happy birthday Bhavik, all of it. So you combine it in multiple ways, and then you see how common that term is occurring in this post versus across your entire corpus. So across every post that you have, how frequently that term occurs, and you realize happy is not. So the idea of using that IDF piece is to understand and to contextualize something. Let's say in a particular piece, happy is going to occur very, very frequently, and so you do not want to give weightage to happy because happy is common, right? So when let's say we talk about politics, right, then government is a very common word, right? Now you don't want to give government a lot of weightage because it would come anyways, right? It's not talking about the specific attribute of an item, it's just something that occurs, right? Just like you in typical English, you don't want to give weightage to is, the, and, right? Similarly, when you're talking about something like politics, you might not want to give a lot of weightage to government, right? And when you talk about sports, you might not want to give a lot of weightage to player, right? So these are things that you don't want to give a whole lot of extensive weightage to, right? And that is where the TF-IDF comes in. The IDF part is where it normalizes it against the occurrence of all the items in that piece. So that is where we create this dictionary bag of words. Now usually what we need to do before we create these bag of words is we need to clean these data extensively, right? Text data has a lot of stuff that does not is not useful, is junk. Text data has a lot of stuff that if you add to your model, one, your model will become slow, and two, your model might not give the kind of results that you are looking for. So you really need to filter out a lot of the data from text, right? So you employ all sorts of techniques from, simple spell correction, part of speech tagging. You identify what stop word removal, you do, tokenization, you do named entity recognition, and you do all of that to learn to remove things and add things that really matter and that don't matter, right? So that is very important when you do all of this. But just a simple implementation of, TF-IDF, this is what IDF is. Term frequency is basically how frequently that term occurs in the document, and IDF is how frequently, that is a measure of how frequently that term occurs across the entire matrix, across the entire corpus of documents that you have. So that is simply that. So this is just an example of how this is computed, right? Now what I'm going to briefly talk about is there is vector prediction, right? Prediction based on vectorization. Now here there is a lot of stuff that you, and actually I'll get into a little bit of details of this, but simply put, what it does is it represents every word as a vector of a large set of numbers. Now the good piece about this is it learns things very well. So for instance, if you take the vector of man, right, take the vector of king, subtract the vector of man, add the vector of woman, you get the vector of a queen, right? Similarly, you take the vector of Spain, subtract the vector of Madrid, add the vector of Rome, you get Italy, right? So that is sort of how this thing works. It learns this nuanced detail about text. It understands the meaning of words in text. So how is this actually generated, right? This is generated using some technique known as the continuous bag of words sort of thing, right? What this is really is, basically what it does is it takes an entire sentence, it takes an entire context, as we say it, and it gives every word in this context and leaves the last word empty or one of the words empty for the model to predict, right? So for instance, it takes the entire context and it says, let's say I have a sentence that says, I painted the bench, and then it leaves the last word as blank. So now it wants the model to predict what will come after I painted the bench. So many things can come after I painted the bench. You can say, I painted the bench yellow, I painted the bench blue. You can also say, I painted the bench today, I painted the bench yesterday. And basis that, the model understands that yellow and blue are similar, yesterday and today are similar. And that is how it generates these extensive vectors which allow you to do some really amazing things, understanding the semantics of a particular thing. So this is continuous bag of words, right? And then the next piece is called skipgram. Skipgram is exactly opposite. It says, it gives you yellow and it wants to predict I painted the bench. What should come with yellow, right? Much more complex when you think about it, but if you provide a lot of data to your model, then that is where you will get a lot of interesting results. So anyway, so that is largely my stuff, right? Yep. And just to give you a brief idea of how recommendation systems work, any questions I'll be happy to answer. Thank you for listening patiently.
Thank you, sir.
Yes. Sorry? Do I what? Do I use an AI tool to do my predictions? You mean in terms of my work at shadi.com and stuff? So no, we use Python and R. I mean, that is the kind of AI tools we use. Obviously, We use, Spark and stuff to extensively analyze and, deal with the amount of data that we have. But beyond that, it's just R and Python and all the libraries, TensorFlow, Keras, all of those stuff. But no specific tool as such. Yeah. Any other questions? Yes, please. Do I think deep learning is an overkill for recommendation systems? So here's, as I said, there is this evolution phase. It depends on where you are in that phase, right? If you really want to take the entire juice out of the system, right? You don't want even 3% of your users to get bad recommendations. Then you really want to go and build as complex models and model systems as you need. But yes, when you are at the early stages of your, product, probably deep learning might be an overkill for it, because, you just, getting into things that will take a lot of time, and you might have other low-hanging fruits that you might want to go after. But as I said, as the industry matures and as the company matures, it really becomes important for you to, get more and more detailed and more nuanced and more complex. Any other questions? Yes. So no, not really. So I would love to be in that phase. In some of our techniques, we are sort of in that phase, but overall, we are still far from it, as a company as a whole, right? We are still probably somewhere in the model system kind of thing, just making sure that we do not give biased results to people. Yes. So there is no clear line. It's not like you are here and so you are in the model, and you are here and you get into the model system phase. It all depends on when that problem becomes big enough and important enough for your company, right? When it becomes big enough and you're like, I can't live with this, right? It is really hurting me, right? So let's say you have 10 things that you want to do, and then you measure how much impact will you get out of that. The first thing is probably going to give you a 12% jump. The second thing is going to give you a 5% jump. The third thing is going to give you a 3% jump. You obviously want to take the 12% first. And the second one is where you go from a model to model system. So once you're done with everything that gives you more than a 5% jump, you want to go to there, right? So again, it's not as crisp and as clear as I just described it out to be, but it's a subjective decision that people take. There is no clear line around it. People estimate the impact, and as a business, it's all about making the customers happy and earning good money, and people focus on that basis that they take the call. Yes, please. Sorry? So the way I'd say is recommender systems, and when we say neural networks, or if you mean deep learning, recommender systems and deep learning are sort of orthogonal to each other. So recommender systems does use deep learning as and when required to improve. We have recommendation techniques which use deep learning, right, which use neural networks. But if you were to ask me, does recommendation system come under neural networks? No. Does neural networks come under recommendation system? No. They are two sort of separate things, right? Sorry? Right. So it is a part of machine learning, but neural networks is, so I was answering specific to neural networks. Yes, of course, it is a part of machine learning. We often, talk about it as a part of machine learning. Again, there'll be people who will argue with that as well, partly. But if you ask me, I would say yes, absolutely, it is a part of machine learning. But in a sense, I'd say it's sort of, when it comes to neural networks, that's a technique, and recommender systems is a technique. Recommender systems is sort of a problem that you want to solve, and then you might use neural networks, or you may not use neural networks for it. Yes. Yes, so we use a lot of different techniques. We use, LSTMs, RNNs, even some places people use CNNs for recommendations, right? Obviously, collaborative and content-based are most common. Yes? Hmm. Right. Sorting phase. That is seriously how everything starts, right? And again, as I said, there is no clear line between when you go from sorting to formula. It bases on how important it is to your business. You sort of make the jump, right? If you are building a industry or a company that is based on machine learning and artificial intelligence, you might want to immediately start with the model phase, right, for that matter. But then it depends on where you stand and where your priorities are. Yes. 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 Noise. Absolutely. Absolutely. Right. So again, there's a lot of sure. Hmm. 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 Yes. Agreed. Sure. So here's how we go about it. The first part that you mentioned about signal and noise, right? So what we do with respect to that, again, it's as I said, it's a, you mentioned it's almost a human judgment. We try and remove as much noise as we can, right? We use extensive, natural language processing techniques. We use extensive dimensionality reduction, feature selection techniques to ensure we remove things that may not make sense. However, I mean, I come from a slightly, I hate to admit it, but I come from a slightly more older school sort of thing where I would want to remove as much noise as possible. But there are people in my team who are like, we train a deep learning system, we train a neural network, let it figure out what's signal, what's noise. I am not going to remove it. Right. So there are people in my team who think like that, and when I compare myself, I feel old school, but I really like to remove as much as possible. I keep telling them that you should remove as much as possible, right? But they, on the other hand, they don't want to spend a whole lot of time trying to figure out what's signal, what's noise. They just want to dump it all on a deep learned model system and let it figure out what's signal, what's noise. Uh, I agree. So at some level you have to do some of it, right? But now what happens is GPUs have come in and become a rage. Dr. Vinay was talking about Spark and stuff. So there is all of these tools that you can use and leverage to use like massive amounts of data. And when that you are able to do all of that, that becomes it becomes a little tricky to convince. For me, it becomes a little tricky to convince my team, you should really remove every single thing. So they do that. It's not that they dump everything, right? They do a little bit of filtering. Obviously, stop words are removed, and spell corrections are done, and punctuation is taken care of. But then what I used to do in my days, and it is like I used to take part of speech tagger and then remove all the parts of speech that were not important to my problem, right? So most of the times I would remove adverbs and verbs and all of that because they were not important. And these guys are like, but maybe there is some verb that is important, and maybe there is some adverb that is important. And so they want to just dump it all on a deep learning system and let the system figure out what is important and what is not. And so they don't want to do the sort of make the judgment themselves, right? They want to let the system do it for them. So that is partly the answer. I don't know if I have a very clear answer on that, but this is what I have. The second piece that you asked is around privacy and ethics. And yes, it's always a big challenge because data science cannot survive without data, and then privacy is where you want to limit as much of the data as possible. What we try and do as far as possible is we try and avoid using personally identifiable information, right? So we try and sort of draw the line at that, as much as possible, we will not use any information that personally identifies a person or something, especially post they have exited the system, right? When my model learns, obviously it learns on a lot of historical data. At that point of time, I don't want to use any PII. I will use historical data of past customers, but I will not use anything that personally identifies them. Obviously, when my model is going to predict today, right, it cannot predict without knowing who it is predicting for, right? And to that extent, there are certain scenarios where, we want to predict it for somebody and with, to somebody. But yeah, we try and sort of draw the line at PII versus non-PII, try to use as much we can from the non-PII aspect of things.
Also, as you talked about, like clustering that anyway.
Yes. So we do that, yes, extensively. So that is one of the ways that we reduce a lot of the PII, right? We go at, instead of going at the user level, we sort of go at, let's say, the demographic level and some activity level. So we have a certain levels of demography, certain levels of activity, and that is how we have different groupings. And that is what the model really gets. The model does not get anything about a particular user. Yes.
Like, can you suggest some systems or tools which can improve personality analysis or the mental state analysis of mental state of a person based on the usage of their application or some
So that is, very potentially getting into the space of ethically challenging things. Right.
like, I'm making an app for the students. Like, there are several students who are quite depressed in the college, and there have been cases of students.
Right. So no, I sure. So there are, if you check, there are a bunch of apps that these days help people with, depression, poor moods. They really help people with that. There are a lot of apps that are already available. You might want to check them out. They will give you a lot of idea around, how they are built. They basically try and, sort of do what I would call as, a kind of active learning, where they ask the user something, and basis the response, they judge, where the user is today, right? And so they ask the most relevant question. The challenge with active learning is to figure out what to ask, right? If you ask the wrong question, you don't get the information you're looking for. So active learning is a space where they try and figure out what to ask. So once you know what to ask, you ask the right question, you get the response, then you can easily judge where things are. Okay, thank you everyone. Seriously, thanks a lot for listening so patiently. Been an amazing audience. Thank you.
Thank you so much, sir, for such a thrilling session. I would now like to invite Head of Information Technology Department, Professor Swati Nadkarni ma'am, to present Mr. Bhavik Gandhi with a token of appreciation.
Thank you, Bhavik, for this such wonderful session. So now with this, ladies and gentlemen, we have come to an end of the first half of the session, what we have discussed in the morning. So now since this morning we have been, we have tasted different flavors of AI, started with the 360-degree view that has been given by Mr. Bhupesh Dahiria. Then we have Dr. Vinay Kulkarni, who have just explained about the Spark part. And recently we have heard the recommendation system, how it works. So post-lunch, so it's the time for lunch. So post-lunch we have another exciting segments, talks are coming up. So we'll be having that how recommended system actually works. So we have our research associate with us. So we'll be demonstrating you the demo, a product demo of the recommender system. Then also we'll be having some keynotes by Dr. Sudeep Roy Chaudhary. He's already there. He's the principal data scientist working with Fractal. So and many more exciting features. And meanwhile, we have Lynx humanoid here. If you guys want to interact with the Lynx, you want to ask any silly or good question, So it would try to respond to your questions. So you can have the selfies, photographs. So it's here for you. Thank you so much. So we'll resume at 2:20 after lunch. Thank you.